Hello and welcome to the shed. Today's lesson is all about vectors and matrices, but more specifically dot products, cross products and triple products. So hold on to your horses, kids, it's going to be a bumpy ride. Right, topic 1, dot products. A dot B, two vectors. You can calculate the dot product by two different methods. There's vector A, there's vector B, and there is angle theta. Right, method 1. Right, method 1 is calculated by A dot B, this dot product, is equal to the magnitude of A times by the magnitude of B times by cos theta. Got it? Good. Number 2. The way to do this one is you have your two vectors A1, A2, A3 dotted with B1, B2, B3 equals A1, B1 plus A2, B2 plus A3, B3. Right, the dot product actually gives the degree to which the two vectors are collinear. Yes, hello?
Whoa. What does collinear mean?
Oh, I'm glad you asked. Collinear is the degree to which the two vectors are on the same line. Another important thing to remember about the dot product is that if these two vectors are perpendicular at right angles to each other, so theta is 90, then, as you can see here, this dot product would be 0. Hooray! That's the end of the first topic. Topic 2. A cross B, or more commonly known as the cross product. The cross product gives a vector that is at right angles to both vectors. It is a very useful operation because if we have 3 points in a plane, we can calculate the normal to the plane by considering the points as making two vectors and obtaining the cross product, like so. What we do is we form a matrix out of the components of the two vectors, like so, and we find the determinant of this matrix. Just like that. That is the determinant of that matrix. Now, an important thing to remember with the cross product is that it is non-commutative. So, A cross B is actually equal to minus B cross A. You have to remember that. Okay? Thank you. Right. Topic 3. The triple product. The triple product is defined as the dot product of one vector with the cross product of the other two. A dot B cross C. It does have some properties. Much like the cross product, it is non-commutative. So, were I to switch two of these, you would put a negative sign in front of it, like so. Negative. Right. But you can also switch, as long as they stay in the same order, you can cycle them however you like. So that is actually the same as C dotted with A cross B, which is also the same as B dotted with C cross A. Got that? Okay, I will now show you how to calculate the triple product, as it is very useful because it gives you the volume of the parallelepiped that's formed by the three vectors. using these three vectors, I'll give this one A, this one B, and this one C. Okay, it's actually quite similar to the cross product in that you form a matrix of the vectors and find the determinant, like so. Here's one I made earlier. Equals 1 times minus 1 minus 1. Take away 2 lots of 0 minus 3. 2 lots of minus 3. Plus 4 lots of 2. Which, if you do this in your head, as a true mathematician, is equal to 13. That concludes the lesson of today. Come back for part 2 of the shed. Thank you for listening.
Math is a wonderful thing. Math is a really cool thing. So get off your act, let's do some math. Math, 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 math.